3J, cubics in power form. Alright, so cubics in power form is very like quadratics in power form and like everything else we've done in power form. Okay, it's about horizontal translations and vertical translations, reflections and dilations. Okay, so your standard y equals x cubed graph we talked about in the last video basically does that. Okay, if it's negative, it'll do this. Okay, so if you look at that, and this is the way I look at it, and it may work for you, it may not. If you look at that, it's all centered around this point right here. I probably should have done that in a different color. Okay, it's all centered around the origin. Okay, so these cubic graphs in power form are centered around the origin. Okay, so when you translate them, and it's the same as how we've translated a heap of things. So the basic form is a x minus b cubed plus c. Now you might have seen this one as h and this one as k. Okay, horizontal for h and k for vertical. I don't know why it's k, but k for vertical. Okay, so this a is a dilation. Okay, which expands or contracts the graph. So it'll actually either push this graph out, pull it in a little bit, depending on what that number is. So it'll either push it out or pull it in. Okay, this h, okay, moves the graph side to side depending on the sign. Okay, if it's moving it this way, it's a positive. If it's moving it this way, it's a negative. It's reversed. So when you pull that out of the brackets, you change the sign. We talked about that in a previous video. Okay, so if you are moving it towards the positive x, then h or b or whatever that value is going to be negative in the bracket. So when you pull it out, alright, so it moves it this way if it's positive and this way if it's negative. Okay, and k moves it up and down. Okay, and that moves it in the right direction. So if k is positive, it moves it up. If k is negative, it moves it down. So that's a standard one. You just need to remember if something is in those brackets, then it's shifting it the opposite of the sign. Okay, and that's going to come in real handy in a lot of stuff we're going to do. Okay, if it's inside the brackets, it's going to move it the opposite of the sign. Okay, so to actually graph these is not that hard. All right, so let's do a little bit of a dilation factor one. So if, let's say we've just got a standard x cubed graph, looks like that. Okay, x cubed. If we had a 2x cubed, what do you think that's going to look like? Is it going to move up quicker or is it going to move up slower? So am I going to shift the graph out or am I going to shift the graph in? What do you think? Why in? Tell me the why. You're right, it is moving in, but why? Why? Yeah, but what's it doing to the graph? What's it doing to my values? If you go back to a table of values here, it's squishing it. Why? Because it's going up twice as fast. Okay, so that 2 means it's going up twice as fast, doesn't it? So it'll actually look like that. Okay, and if I had 1/2, okay, instead of the 2, it's going to push it out, isn't it? It's going to go up half as quick, so it's actually going to look more like that. Okay, so that's what dilation factor does here.
Oh, so it makes it go up or quicker as well?
Yes, basically. So it actually compresses it this way, but what it's actually doing is making it go up. It goes up faster or up slower. Yeah, all right.
Like if you're going down a hill,
yep.
like skiing.
Yeah.
Shush.
Yeah, do it, yeah.
If you're going down a hill skiing, if you go like on an angle like that down the hill,
yeah.
you go slower down the hill than if you go straight, you go
yes,
fast.
Yes. So this is making things go faster. The 2 is making things go faster, so it makes the hill steeper. This half is making things go slower, so it's a less steep slope. That's fine. If that's how you remember it, that's perfectly fine with me. All right. Did you have a question?
Yeah, so if it's a whole number, like a positive whole number, that makes it go up quicker.
Not just positive. If it's above 1 or below -1, okay, so if we ignore the sign for a moment, because all the sign does is flip the graph, okay, invert it, okay. So if you ignore the sign for a minute, if that number, that A, is larger than 1, it's going to make it go up faster. If it's smaller than 1, So if it's between 0 and 1, it's actually going to make it go up slower. Okay, and then you take your sign into account afterwards. The dilation factor is not affected by the sign, only the basic shape of the graph is. Okay, so if we go back up here and just confirm that, okay, the negative just makes your graph reversed, okay, as opposed to the standard way we see it like that. That's the only thing the negative does. It does not affect your dilation factor at all. Your dilation factor is something separate. Okay, so you can use your dilation factor as something completely separate when you're doing your calculations. Alright, so now let's just run through some examples because that's the best way to sort of talk about these guys. Alright, so let's do question 1a. Y equals 2, x minus 1 cubed plus 3. So let's talk about what we've got. Can I get this up at the same time? I can. So if we just put that there. Okay, you can't see what k does, but I'm sure you can remember that k moves it up and down based on what that number is. Okay, so let's talk. What's it going to be? Compared to our normal graph. Okay, so a normal graph looks like that. So my dilation is squished which way? So this is going to make my graph steeper, right? So it's going to look like that. Yep. So let's pick another thing. What's this going to do? Move it to the positive 1, all right? So it moves it this way 1. So this way 1. Okay, so then it's going to be the same steep, it's just going to move that way 1. Okay, and then what does this guy do?
It's going to move it up.
It's going to move it up how many? So I've got to move that whole graph up 3, so it's actually going to do that. So, remember I said everything is...
Could you draw like a mini graph?
I'm going to draw it properly in a second. I was just talking about that. Alright? So remember I said everything is centered around this origin. Okay? So what have we done to our origin?
Is this that dotted line thing?
No, different exercise. Alright, so we've moved it this way 1 and up 3. So what used to be 0, 0, okay, what used to be here, is actually now over 1 and up 3. So it's actually here. So that's the center of my graph. Okay, and then you just draw your graph. You worry about your steepness. It's a terrible graph. And there's one more thing I have to work out, and that's the Y-intercept. Okay, so when you're sketching these, you still need to work out the Y-intercept. So how are you going to work that out? Yeah, you let x equal 0. Perfect. So if we do that, we'll let x equal 0. 2 times 0 minus 1 cubed plus 3. Minus 1 cubed is minus 1 times 2 is minus 2 plus 3, and that is 1. So that value there is 1. Okay. Now you could try and work out the x-intercept as well if you really, really wanted to, but I don't think you actually need to. Alright? Makes sense? When you are doing this though, you should write down what your point of inflection is. Okay, so that point, that center point of your cubic graph, you need to write that down as well. Okay? Which is 1, 3. Alright? So we'll do some more in a second. Okay, so let's have a look at another question. Let's have a look at 2b. We've got the equation y equals negative 3, x plus 3 cubed plus 81. So let's again, our standard graph will look like what? Will it do this?
It'll be squished.
Alright, so let's start with our standard graph looks like that. Alright, and then let's talk about what happens next. What's the first thing you think I should do?
Flip it.
Right, flip it. So this means you flip it. Now it actually means you flip it this way. Alright, believe it or not. It's not flipped this way. It's actually flipped this way here. So it's not flipped that way. Alright, so that's important later, okay, which way we're flipping things. But at this point we're flipping it that way, up and down, so we end up like this. Okay, that's our standard negative x cubed graph. Okay, now it's squished by a factor of 3, so we're coming in. Okay, and then what are we doing next? Which way are we moving? We're moving that way 3, aren't we? So we're going to move it over here 3. Okay, and that's going to be 3. And then what's this tell us to do? Move it up 81. So we're going to move it up 81, so it's going to stay roughly there, and we're just going to do this. Alright, and my point of inflection is 381. Okay, and I need to find the y-intercept, so if we let x equal 0, negative 3, 0 plus 3 cubed plus 81. 3 cubed is 27 times negative 3, negative 81, plus 81, 0. So it actually crosses at the origin there. Okay,
Yeah.
so then I would of course redraw my graph nicely and say, well, this point here is negative 3, 81. It's going to go through there, so we're going to come down through the point of inflection and back down through where it equals 1, where it equals 0. All right. Okay, the last thing we may need to do for this exercise is work backwards. So if you have a look at question 7 or even question 6, it talks about suggest an equation for this. What is the equation for these graphs? So I'm not going to do question 6, but we'll have a look at question 7. It says dilation of 4 from x, stationary point at 2, 3. Okay, so if we've got a dilation of 4, we know that our a x plus, what do you want, b or h or what? Does it matter? Do b, cubed plus c. Okay, so where does my dilation of 4 go?
A.
So 4 goes here at a. Okay, now my stationary point has 2 points in it.
Does that mean that's a point of inflection?
Yes, it does say point of inflection in the question, I just didn't write it all. So that's a, what is it? That's a 2.
B is B minus 2 and C.
Alright, B is negative 2 and C is 3. So it's positive 3 because it's positive. So when you're putting it back in, alright, so when we put this 2 back into the equation, you need to change the sign. Alright, don't forget that. So it's negative 2. So my end equation will be y equals 4, x minus 2 cubed plus 3.